Well, welcome to this next tutorial, and today we're going to be doing a project. Now, as you can see on the screen, we've got a picture of a level crossing, and that's what we're going to be building today. So this is a level crossing from my childhood youth, Purton Crossing, just south of Worcester in the Midlands. The reason I picked this particular crossing is there's very little traffic, so I'm not going to get run over while doing the video. And what we're going to do is build a model of this, a breadboard model. The reason I haven't built the full model is my layout doesn't require level crossing. But if we look at this model, we've got the servos to represent the gates. We've got some orange LEDs, some sets of red flashing LEDs, and some constantly on red LEDs. So we're going to build a project that mimics this crossing and that can be used on a layout and stopped or started by whatever you want. So let's get started. So before we get into the coding, let's just take a look at this crossing setup, and what I'm going to do is show you a video of the whole crossing sequence. Thankfully it's not too long. Now, the reason for going through that whole video was to see the complete sequence of lights that start with an amber light, then you've got a couple of red lights. Basically, I went through the whole system, timing each item to make sure that I got the sequence correct. And now I'm going to show you a video of the breadboard finished version. So that was the sort of finished version in action on the breadboard. Let's have a look at what is going on. So for this project I'm using an Uno, and although my breadboard version only has two servos, and you'll notice one was moving clockwise, one was moving anti-clockwise, this is because the particular barriers that I'm looking at, there's only two barriers. The closest level crossing to me, Henwick Crossing, actually has proper 4 barriers, and that means that if you're making a model of that, you're going to require 2 clockwise and 2 anti-clockwise sets of barriers. So the way this is going to work, if we look at the PCA9685 board up on the top right here, the first 2 ports, 0 and 1, both will go clockwise. The others, then 2 and 3, go anti-clockwise. So although I've got this set up on the breadboard for 2 servos, I could plug another 2 servos in and be able to do a 4-gate system. If we come down now to the PCA9685 board on the left, 0 to 3, so these top 4 ports here are the amber lights. So there's 4 sets of flashing lights, so we're going to need 4 ambers. Then we have the next 4 are going to be one side of the flashing red lights, and then the next 4 after that are the opposite side, if that makes sense. So one is flashing on while the other is off, and these two swap between each other. I've then used these 4 ports down here for a constantly on LED, another red LED that is there to represent the LEDs that are on the actual barrier. So if we go back up here, there were some LEDs on the barrier. We've got a orange light in the center, then the 2 reds. When it first starts, you actually get periods where both lights are on together. It's just as they switch over, one is going dim while the other is coming on. But so we've got the flashing alternate ones, another flashing pair, obviously the other side of the road, the ambers in the center, and then we've got these red barrier lights, and of course the barriers move up and down. So that is what I have built. Obviously I haven't put all the LEDs in the circuit because it would start to become confusing, but we're going to be using 2 PCA9685 boards. Now I've just done a tutorial on using multiple PCA9685 boards with servos and LEDs. If you go to the Digital Town website, if you go to the bottom of the page that's associated with this project, you will see number 55, multiple PCA, and there's various other projects that are linked to this, including examples of using a state machine code and not using delays and millis, because using millis rather than delay, because this code is written as a state machine, because we cannot have delay in the code because it'll mess everything up. So that's the circuitry. I have set this up for an Uno, but because I'm only using a couple of PCA9685 boards, I've got the connections below here if you wanted to use a Arduino Mega, ESP32, virtually any board that's got an I2C port on it can be used. Just a quick one, as we're looking at the circuitry, there is a VCC pin that's getting 5 volts from the Arduino. That is to power the circuitry on the PCA9685 board. The 5 volt supply is coming into this board, and you'll see it's going round onto the other board as well. You need a separate 5 volt supply. Big warning on this, because if you don't, your Uno is really going to have a bad day, because it's not designed to supply enough power for multiple servos. Even the USB off your computer is probably going to have a pretty bad day, and just get yourself a separate 5 volt DC supply and put it in place. Right, how the project starts. Obviously I'm not going to go through everything to do with how this works, because if you look at that previous video number 55 on multiple boards, that'll give you a bit of a heads up. But the first thing that I want you to do when you're doing this is do the connection test. For that we go into the Arduino IDE, we go File, Examples, down to Wire, and then I2C Scanner. Run the I2C Scanner, and you will see something like scanning I2C device found at address 0x40, hexadecimal value 40. That tells you that you've got your boards connected. You're going to need 2 boards with different addresses. To change the address, you need to solder across one of these pads. Run the I2C scanner, and you will see both addresses again. It's in that video number 55 if you want to find out how to do that. The reason for doing this test is most of the issues that I come across when helping people with any kind of project are wiring problems. This tells you that you've got everything connected properly. That's a good start. Otherwise you're going to be looking for a problem in the code and the problems in your wires. Next, you're going to need to make sure you've got the Adafruit PWM servo driver library installed. Again, on the web page, there's links to how to do that. I'm not going to go through it on a blow-by-blow example. You can actually do a servo test as well if you want to do that. Anyway, let's get to the code. So here's the first sketch. It's one of two. One is a simple sketch, the other one is a little bit more complicated, but the effects are slightly better. So first of all, let's, the basics. Get the wire library and the Adafruit PWM servo library installed. We've then got the servo board is set up on mine to the default address of 40. The other servo board I've got set to address 46. This is to do with, you set the addresses on these boards by soldering across these tabs top right. The reason it's address 46 on mine is that's just the board that was lying around on the workbench. There are some items in here that you do not need to worry about. They need to be in there, but just leave them alone, because mess about with them, you're going to mess about with the project. Right, let's go down to the setup. So in the setup, we begin the servo board, we set the oscillator frequency, and we set the frequency of the PWM frequency to 50 Hertz, which is perfect for these servos. We then do a similar thing with the LED board, except this time we set the frequency to 1600 because LEDs prefer a much higher frequency. That's because if we put a lower frequency, we would start to see them flicker, and we do not want that. Small delay while we just let all that take effect, and then just some startup code. So what I've done here, I've gone through all 16 ports of the LED board and I've set it to a value of 4096, which means the LEDs are all turned off. Then what I've done is gone through ports 0 to less than 2, so 0 and 1 I've set to a position of 0. Ports 2 to 1 less than 4, so 2 and 3 I've set to 179. Don't forget, one of these is moving clockwise, the other is moving anti-clockwise. Depends on which side of the road your barrier is, whether you want an anti-clockwise or a clockwise barrier. So I've put both in, but basically this is moving both the servos back to their starting positions. Now, once everything's in its starting position, let's take a look at the main loop. There's not a lot in there. Now, the first item is my favorite little variable, current millis. If we go up to where we've got our variables, we have it here. It's an unsigned long. This stores a value in milliseconds since the board started. I always put it at the start of the main loop, and then I use it throughout the different functions that I call, because we're going to be using millis to control the timings of all of these things. Right, the next function is an important one, gate trigger. Now this is the item that causes the gates to move. Now if we go back up to this function, there we are, and then just switch over to our wiring diagram, you will notice there are no switches, buttons or anything else. I'm actually using time to start and stop the code. You can switch it to buttons without any problem at all. So let's have a quick look at this. The gate trigger, what it basically does is it checks the state of the LED, because obviously I don't want to trigger it if it's already triggered. Then I'm using this timer here, so I'm restarting the thing 10 seconds after it was last triggered and everything was shut down. If I was writing this for my layout, I would comment that one out, comment that one out, comment out the other end of the if statement, and then what I'd be typing in here is something like if digital read, sensor pin is greater than 0, then trigger these items. So I'm using time, but to change this to be triggered by something else, literally this is where you would put that bit of code. You'd make sure it's inside the if statement, but it's basically here is where you'd go, and you set the LED state to 1, and you'll see what that does in a bit. The same when my trainers pass by, the trigger for the gates to go back down, it's basically saying if the gate state is smaller than 2 and the LED state is equal to 5, then gate state goes to 2. We'll go through the states in a minute, but again, if you wanted to trigger this with a button or something like that, you would comment out the timing system and just put your if statement around for whatever trigger you require. So the trigger, gate trigger, is just the thing that triggers the gate procedure starting and the gate procedure stopping. The next function in the main loop is the LED control. Guess what that does? It controls the LEDs. So let's get up to this particular function. Now, the way I worked this out, I was very boring. I watched that video of those gates, and actually I watched a previous video, but that was filmed near a gale force wind, so it wasn't suitable to show on the video. But basically I sat there watching the video and timing things to work out when things actually happened. And even now I'm still not sure I've got it perfect, but it's pretty close. So we're talking about state machine code. So we have a variable called LED state, and that keeps track of where we are in the system. So we're going to start with, if the value is 1, and I'll be honest, I increment through the system. So state 1 means if we go to our trigger, when we want to start the system, we set it to an LED state of 1. In the main loop, it then calls this function. It says, hey, we've now got a state of 1. So we're going to start by setting the lights to orange for 3 seconds. So it sets the it does a quick check first to check that the current LED state is smaller than 1. The reason for this is it's going to sit in this loop. It's going to come back to this possibly a few times before it jumps to the next state. So I want to make sure that it doesn't try starting the LEDs more than once. Anyway, if that's not smaller than 1, set it to 1. And then what we're going to do is we're going to set on the board the first 2 LEDs to on that board are going to be set to be fully on, which is 4095. The other thing I've done is ports 12 to 16. I've also set those on. Now those are the red barrier lights, which as the barrier lifts is always on. I'm then resetting what's called the LED timer, which keeps track of the timings of various things, and we're going to set the LED state to 2. Now I'm going to serial print out the LED state. This is just so that you can see in the serial monitor, if you're running this code, you can see where it's actually got to in the code. Now that means our orange lights are now on. The timer is started, and when we go into the next one, it's waiting to make sure that the LED timer has basically we've waited 3 seconds, 3000 milliseconds. Once those 3000 milliseconds have passed, the 3 seconds have passed, that's how long I timed on the video that the orange lights were on. So now what it does is it turns the red lights on and the orange off. So turn the red lights on, turn the orange lights off, set the LED state to 3. So we're waiting to go to the next section, and set the LED timer to current millis. Now what happens is all the red lights come on, and then all the red lights all go off. So basically after half a second all the lights go off. We reset the timer, we go to the next state, the reds come on, and we go through this, let's turn all the red lights on. That's what we do, and that is right before we go to state 5, which starts the flashing. Now you might be wondering, well, why on earth didn't he just set the values, put delay in, and just work through that way? Well, the reason is, if you use delay on all of this stuff, any triggers that you have cannot be activated while the board is in a state of delay. So you'd actually have to wait till everything had happened before you could press the button. Now once we get to, and of course I do want to add some extra bits later on, like sound. So what happens next is we get to an LED state of 5, which then starts the flashing sequence, and at the same time we've got a gate state of 1. That is then to do with when the servos will start to move, because don't forget, we've now, if you remember back to the video, there's these initial flashing of lights and squealing of sirens and stuff like that, and then when the drivers have had time to stop, the gates start moving. So a few seconds have gone by. So gate state, LED state 5 down here is basically I've got one set of LEDs flashing one way, one's flashing the other way, and it's looking at a variable called flash state, and it keeps changing the value of flash state between 0 and 1. You can see I've reset it here and I've reset it here, and it's basically saying if it's one way, flash the left hand lights on, the right hand lights off, and then the other way, left hand on, right hand off. That's all it's doing in there, and it will keep looping this LED state 5 over and over again until eventually flash state 6 is called, LED state 6 is called, at which point it turns all the LEDs off. Now going back to our gate state, that takes us back to the main loop and the servo control, and when that LED, that state is called, if we go up to the gate trigger, so sorry, not gate trigger, I've lost the where are we? LED control, scrolling down, servo control, right. So it's looking at the gate state. If the gate state is equal to 1, case 1, we lower the barriers, and all it does then is it sets both sets of barriers to a value of 89, which on the servo is 90 degrees, because servos start at 0 and finish at 179. So 90 degrees is 89 degrees. Yeah, weird as it is. So that then raises the barriers, and then when the trigger comes to, if we go to our trigger code, so I've got my gate trigger, when it is time to lower the barriers, he says, looking for the gate trigger, what I then do is I set a gate state of 2, and when the gate state is set to 2, it moves the barriers back to their starting position, It then sets a gate state of 3. This is an odd one, so the servos have all moved back to their starting position, but when it goes to a gate state of 3 and it sets the timer, basically it waits 1.5 seconds, and after 1.5 seconds it sets an LED state of 6, and that turns the LEDs off. So it's using these different states. That's why this type of code is often called a state machine. You're changing the state of things, but this code means that I could add extra items in, and as long as I don't put any delays in, everything will run. Now let's take a look at this code running. Apologies for the background noise. In the video I was doing some 3D printing and I couldn't wait the 11 hours for the print to stop. Now if you think of that video, the one issue with it is all the LEDs are fine, but when those servos move, the speed that they're moving, a real crossing gate, it would just snap the barriers off. You know, the G-force would be too much. So although that sketch works and the barriers move, for me I wasn't happy with the barrier movement, and that's why I wrote version 2. Now if you're wondering why I didn't just go straight to version 2, well, let's be honest, version 2 is a little bit more complicated. Not a huge amount, but a little bit more complicated. So let's go down to the main loop to start with and go down to the main loop in the other version. Now we've got our current mill is, gate trigger, LED, servo control, all of that remains the same in both sketches, or most of it anyway. The big difference is we have added a new function called servo movement. Now when in the first sketch, when I wanted to set a servo's position, if we look at the code here, we've just taken the servo number, the port on the PCA9685 board, and we've set an angle. In this version we're not going to do that because the servo is going to be moving in a set of steps, as we'll see in a moment. So the first thing I had to do, let's widen this up a bit so we can see the whole sketch again. If we go to our variables, I had to add 2 new variables in. The first is the servo movement timer. This is going to be a timer that moves the servo in lots of little steps so that the movement is slower. Then I've set up an array. So 4 servos, 0 to 3 are their port numbers, and they each have 2 items attached to them. One is what I call the target position, and the other is the actual position. Actual position is the current angle that the board is at, that the servo is at. The target position is the angle that I want the servo to get to. So now if we go down to our servo control function, let's just find that in here. There we go. So everything is the same apart from when we get to set the servos themselves. So if we go into the other one, as we were setting those servos, we just put the servo number and the angle we want into this function, set servo position, and that moved the servo immediately to the angle we wanted. In this one, instead, we're putting those values into the array. So we're saying, on one hand, I want this servo to move, its new target position is to be 0, and here I want the target position to be 179. That's for raising the barriers. For putting them, lowering the barriers, I want 0 to 89, and again 0 to 89 for all the barriers. The reason for doing it in 2 sections here was just for clarity. One of the clockwise barriers, one of the anti-clockwise barriers. Now once it's got that position, If we go down in the loop, there is a function that is called every time the loop goes round, and this function, servo movement, very simple function. What it does is its timer this time is every 0.05 of a second, so this is running quite quickly, and what it's doing is it is checking, is the servo position target greater than the servo's current position. If it is, increment the servo's current position and move it to that angle. Notice it does that every 0.05 of a second. If that servo, if the target position is smaller than the current servo angle, then decrease the current servo angle and set that and send that across. And what that means is that every 0.05 of a second the servo is going to move by 1 degree, and if we now look at that video you'll see the difference. So as you can see in that second video, the servos are moving at a speed that the barriers will stay attached. Now, I hope you've enjoyed the project. Again, if you want to know more, I haven't gone through all the details of how this works because I've done these previous tutorials. If you go to the Digital Town website, you can download all the code and also see the other tutorials that built up to this current item. So I hope that's been helpful. I hope you get to build these sort of projects if you want a sort of British style crossing, then this is the code that you can use for it. Again, if you wanted to trigger sound, you could attach a DF mini board to it and just add those extra bits in as you wish. But I hope you enjoyed that, and if you do, please click the like and subscribe. Bye for now.